All right, in the last video, we talked about how we can interpret the partial derivatives of a function with respect to x and y as the slopes of certain curves on the surface. So in this video, we'll kind of show off what that means. Let's use the example here, f of xy equals 1/2 x squared plus, or x squared minus y. So this is a saddle, right? Remember this from the section on quadratic surface. All right, so how can we see what these are? Well, so what we're gonna do is we're gonna take these partial derivatives at this black point here, middle. So make the surface a little more opaque, or sorry, a little more transparent. And then we can see, we change the y value and the dot moves in the y direction. Change the x value and the dot moves in the x direction. Right, so let's put it back here for a minute. So when we're thinking about the partial derivative of a function with respect to x, we're saying it's the rate of change the x direction of. So what are we doing here? Well, what that means is we have to fix a particular value for y. Because remember, sort of the way we compute partial derivatives, the equation for the definition with the limit, y is kind of a constant there. So when we're interpreting this in the graph, we have to think of y as a constant. In other words, we're stuck on this plane here. Okay? So this is y equals whatever it happens to be. About 0 there, negative over here, positive over here. But as you can see, the y value doesn't change. And if we let the x value change, we can see we get a curve here. In this case, it's a parabola. You might remember this when we're talking about traces. Anyway, so how do we see partial derivative? What does it mean? Well, it's the slope of this parabola here. So you can see right here, there's this green line, and that's the tangent to that parabola. So the derivative is the slope of that line. You can see it kind of getting longer there as we go up because the derivative is getting bigger. Very tiny down here, bigger over here again. Right? So yeah, let's see it without the plane here. You can see it's the slope of that line. That's df dx. So here, let's bring in the values here. Right, so you can see what happens as x changes. Likewise, we can do the same thing for y, for the y partial derivative. In that case, we have to think of x as x. Right? And now we get a curve that kind of goes in the y direction. And then the slope of that curve is the partial derivative with respect to y. And again, you can see that changes y as you move x around. You see what happens. Okay? So that's basically the idea, is the partial derivatives are the slopes of these two kinds of curves, the ones that lie in x equals constant or y equals constant are type curves. Okay? So I encourage you to look at this for some other surfaces, move the values around. It might be kind of interesting to try, like move it to a random point, say something over here, and guess, is the derivative with respect to x going to be positive or negative here? The derivative with respect to y going to be positive or negative? And then you can check these two boxes and see if you were right. Okay?